let me first show you a brief table which explains everything. So there are 6 digitalization degrees. The first 2 belongs to the ship digital model. The second 2 belongs to the ship digital shadow. The last 2 is for ship digital twin. Here you see levels, 1, 2, 1, 2, 1, 2. So sensor fusion is not available in the ship digital model, of course, because there are no sensors. It has no connectivity with the real world, but it is available for the others, ship digital shadow and twin. Human control, you completely control ship digital model first level. You partially control the next level because there's a controller inside. In the ship digital shadow, there's the first level, there is human control. In the second, again, partial because you also, again, have a controller. In the highest degree, in ship digital level, you do not have any human control. You might be just watching it, interfere or intervene when needed, but the system just continues by itself, is able to continue by itself. Model fidelity, in the ship digital model, it depends on the kinematic model that you're using. It might be low, it might be high. In the ship digital model, there are sometimes no model or generally low fidelity models. But in ship digital twin, if you want your twin to be capable, you have to have high kinematic models, high level, high fidelity kinematic models. The feedback is visual in ship digital model. Again, visual in the ship digital shadow, but there is some estimation in the second level of ship digital shadow. And for the ship digital twin, you provide feedback with the estimated states that get out of the sensor fusion module, which are being fed by the sensors in the ship and also high fidelity kinematic model. AI models, you do not need to have AI models in the first 5 digitalization degrees, but at the last one, you have to have to be able to correct itself, for the ship to be able to correct itself. If we compare these to the IMO autonomy degrees, ship digital models are not available in the IMO degrees. Ship digital shadows might be 1, 2, 3. Again, ship digital, both levels might be 1, 2, 3. Ship digital twin should be, by definition, level 4, because it's fully autonomous. And here, I'm saying this because I think to be able to go to the 4th level of IMO degrees, that's one of the key things that I want to explain today. You have to have a ship digital twin to be able to go to the 4th degree of IMO autonomy. And that is complete virtual replica of the physical ship with automated decision-making algorithms enhanced with AI and ML models. Okay. The term ship digital twin is important, but in the maritime industry, it is often used for basic models that lack two-way data flow or the ability to function independently. Now I will show you some examples. These, let me warn you beforehand, these papers, I will show you 4. These 4 papers all have digital twins in their titles. I don't want to show the titles and authors of these papers. I don't want to target anyone, but I will only show the abstracts. I will let you read those abstracts and decide if they're actually digital twins. And we will also give you polls, right, Serdar, Professor Serdar İnce? Maybe you might use your knowledge for today to select the best answer. Okay, so the first paper looks like this. Let me read it. In this paper, full-scale data for 2 ships have been used for the comparison of 5 different added resistance methods. The effect of using separate wave spectra for wind waves, swell on performance prediction has been explored. If you look at all these red underlines, you will see that some. I wanted to make things easier for you. Most of 70% have voted for the digital model. Yes, this is actually a digital model because you see here performance prediction, simulation model, speed and power predictions. So all these actually, if you read the paper, of course, this is of course very basic knowledge for the paper, but if you read the whole paper, you will see that it's only based on simulation models, which is actually a digital model in this paper. Shipping is responsible for approximately 90% of world trade, leading to significant impacts on the environment. As a consequence, a crucial issue for the maritime industry is to develop technologies able to increase the. So yeah, there is, 55% have voted for the digital shadow. About half voted for the other. This is actually a digital shadow. Why? Because it says here, they say that digital twin of the ship is being built leveraging on the large amount of information collected from the onboard sensors and used for estimating the speed loss. So where is the bidirectional data exchange? I mean, this is the definition of digital twin. They only use this for passive monitoring. I mean, they don't give any feedback. They don't do the information collected from the virtual world and feed it back to the physical ship. That's why this is actually a digital shadow. Next one. Digital twins have much attention in the shipping industry, attempting to support all phases of a vessel's life cycle. With several tools appearing in digital twin software suites, high-quality maneuvering and performance prediction remain cornerstones. Propulsion efficiency is in focus while in service. Simulator-based training is in focus to ensure safety of maneuvering in confined waters and harbors. Prediction of ship's velocity and turn rate are essential for correct look and feel during training, but phenomena like dynamic inflow to propellers, bank and shallow water effects limit simulators' accuracy. And master mariners often comment that simulations could be in better agreement with actual behaviors of their vessel. This paper focuses on digital twin enhancements to better match reality. Using data logged during in-service operation, we first consider a system identification perspective, employing a first principles model structures, showing that a complete first principles model is not identifiable under the excitation met in service. We employ a recurrent neural network to predict deviations between measured velocities and the model output. The outcome is a hybrid of a first principles model with a machine learning generic approximator add-on. The paper demonstrates significant improvements in prediction accuracy of both in-harbor maneuvering and shallow water passage conditions. 11% said digital model, that this is a digital model. 42% said that this is a digital shadow, and 47% said that this is a digital twin. Actually, I'm surprised here because I thought many people would say digital model looking at the simulator-based training, prediction of ship velocity. So it sounds like it's being talking about a digital model, but it's actually a digital shadow. Why? Because you see that the velocities are being measured and also being fed into the simulator. Why is it's not a digital twin? Again, no bidirectional data exchange. It doesn't do anything. It just collects data, tries to enhance the prediction accuracy, but doesn't do anything return. I mean, this collected data does not return back to the ship. That's why it's not a digital twin. And I think, I mean, if you read the whole paper, I think everyone will agree with me. Actually, this is a digital shadow. Okay, the last one. The advancement of a intelligent technology has propelled the development of smart unmanned vessels into a new phase. To address the urgent demands of current smart ship development, this paper develops a comprehensive ship digital twin system based on a virtual real mapping algorithm, focusing on the fundamental elements of digital twin model construction. Using the smart unmanned experimental ship Dolphin 1 as the prototype, a digital twin virtual model is proposed. This system leverages real-time internal and external data from the entire vessel to track its navigational status, performance indicators, sailing trends, and surrounding flow field information, offering coordinated human-machine navigation assistance. Based on historical data collected from the vessel's long-term navigation, a real-time precise prediction of the vessel's navigational state and hydrodynamic performance is conducted using physics-informed neural network algorithm. This establishes a self-learning, iterative, virtual physical mapping model that enables autonomous updates and evolution. As the real navigation data of the vessel continuously update, the virtual model can more accurately simulate the vessel's state in real time. The proposed digital twin model has been tested through sea trials under real sea conditions, demonstrating its high accuracy, robustness, and potential for enhancing navigational safety and efficiency. This system marks a significant step forward in the integration of digital twin technology with maritime navigation, providing a valuable tool for the future development of smart shipping. So half of the audience said that this is a digital twin. Yes, it is a digital twin. Actually, it says, here, it says, this establishes a self-learning iterative virtual physical mapping model that enables autonomous updates and evolution. If we're talking about evolution and virtual physical model, interconnectivity, then this is definitely a digital model, digital twin, sorry. So yes, okay. Let me talk about the evolution of the operator now. Traditionally, a ship captain controls the vessel directly from the wheelhouse. Digital systems on conventional ships acts only as support tools. They provide data in a digital shadow that doesn't exert control. On more modern ships, on more modern vessels, pilot assist systems provide greater precision, but the human captain remains the ultimate authority. They shift to a supervisor who oversees automated actions. The industry is currently in this transition towards supervisory control. So I'm talking about the current trend. The next step, however, is the ship digital twin, which uses AI, artificial intelligence, for increased autonomy. Here, the operator's role evolves further, and the level of autonomy is determined by how much AI directly manages the ship's functions, as I told you in the ship digital twin levels. In the ship, of course, probably these levels are prone to increasing. Ship maybe STT level 3, STT level 4, because we are only seeing the first initial phases of AI right now. I don't know where it will converge. Maybe we might be talking about very advanced stuff from 5 years from now on. We cannot oversee the future, but today, in our perspective, I think utilization of AI is enough to be counted as the highest level, but probably there will be more levels in the future.